Yes, class. Good evening. Am I audible to all of you? Yes, hello?
Good evening, ma'am.
Or so it's audible for all of you. Yes, good evening, Sneha. So, Sneha, you'll continue in this batch only? Just see whatever timing suit you. So, in the last class, okay, it's just for a month. Fine. No issues. No issues. See, basically we had started with this lesson, that is your chapter number 5 of NCRT, and today we'll finish off this because as Earth magnetism is also not included in your course, just a basic classification of magnets are left, and we didn't do questions on these topics, electrostatics, magnetostatics, and all these. So we'll be focusing on the question part first. We'll do the question part today. Now, what the things were that we discussed? The things that we discussed were the classification, differentiation of electrostatics and magnetostatics. What all differences come in this? So, electric charge we have here magnetic charge. SI unit has the difference. Then electric dipole moment, both have the dipole moment. Magnetic dipole moment is very important. The way electric dipole moment was very important, similarly magnetic dipole moment is also very important. In today's class also we'll do some questions where magnetic dipole moment will be used. Then electric field, magnetic field. Same equatorial and axial positions. Torque, it is equal to Pe sine theta in case of electrostatics, it is Mb sine theta in case of magnetics. Then work done and energy and all these things. Few questions we had seen. We have to do more questions. Okay, before that, let me show you your papers. So Sarah is in this batch. No? Sarah, did you give the test? Yes, Sarah gave the test. So Sarah, what was the mistake? All right, Sarah's. I think in your this is different. You must have received the score no on WhatsApp, Sarah. What's the score over there? Is it 13 on 15 or something else? So, Akifa, she hasn't joined. Krishna has joined. Yes, Krishna has joined.
Yes, ma'am.
Krishna's was full 15 on 15. So anyone who is having issues in any of the questions, let me know. 14, no? Yes, I remember because then some changes were made. So it's 14. Just remember to mention the directions. Hamza is there? Is Hamza present right now? All right, Hamza is present. So Hamza, as usual, you're perfect paper. You write all the subjective tests well. Yes, Hamza, again, the direction. Same thing, direction. Everyone has done the paper well only. It's just that the errors in direction are making. Just the direction issue. Rest of the things are fine. So Kulsum's also score was fine. Who all have joined? Huzefa has joined. Hiba has joined already. Hiba is there. So all of you have done, and even in the other batches this was conducted, most of you have completed the test perfectly. It's just that, did Hiba give the test? Yes, Hiba appeared for the test. So 14 on 15, same thing, direction. Just the direction is missing. All of you do remember to add the direction. So I think only these many students have joined right now. As other students will come, I'll discuss it. See, class, whenever you are appearing for your entrance examinations, their things are different. You have MCQs present. So even if you are not getting the thought of writing SI units or the thought of writing directions, in the options that will be mentioned, and in some of the options it is given in such a manner that you're able to answer it by looking at the unit. Like you'll see unit is ampere per joules, let's say some things unit is, then you'll obviously get a hint that you have to divide current by energy. That's why you're getting this kind of. But in your 12th class board examination, the marking scheme that is present, no, half scores are present for each step. for writing the units, for writing the direction. And in the first question, especially direction was asked. Like most of you, maximum of the students have not. I think it was only Krishna's paper who has done every question, and in every question, even whether asked or not asked, even when where the magnitude was only asked, he has calculated the direction. If it's a vector quantity and if you write only the magnitude, then it's incomplete. How will you get it? And you cannot predict the paper. Prediction of paper is so different. It may happen that you can get a lengthy paper which you are not expecting and the paper you have not done. So if you're fluent with these things like units and these all little mistakes that we commit while writing, then even if the paper is lengthy, then you will be able to do it on time. Like I tell you my case, when I was appearing for my board examination, the physics paper that we had in that year, we had in this Delhi zone that the paper came. It was very, very lengthy. In India, or even for the papers that you also have, we have different zones for the board examination. And for the Delhi zone that it came, it was very, very lengthy. Such a paper we haven't ever practiced. So the students in that year, during that year, all those students whose speed was slow, either they couldn't complete the paper or students who were able to complete it. Most of the students couldn't complete or write everything properly. So papers can be unexpected. Like whatever papers you'll be getting during the time of your pre-boards, it can happen that the questions exactly come, or it can happen a sudden new paper come. So if you're in a habit, why am I taking these subjective tests? I'm taking these tests just in order that you people have the full idea of how to write it. Otherwise, getting the answers, you people still get the answers. Most of you are able to solve the questions. So it's better if direction and magnitude, everything, you just write everything from your side for board examinations. Definitely for entrances, you will have options. Options will be confusing. That's a different thing. When you're preparing for entrances, like the class you are taking, Krishna is, I think, taken, and others, there you see just focus, their classes are just focused on entrances. Right now, you have to focus on your board exams also. And it is not difficult to get a score above 90. Even the papers that we had, which had the syllabus more than you people, we all were able to get above 90. So anyone can get it. Even you have the syllabus even lessened, reduced syllabus is present, most of the topics are deleted. So you people will be able to get it. It's just that if you get the grip of small little things. Otherwise, maximum of you get the correct answers. I think all of you. Sneha's sheet I have not placed because I think I have received it late now, Sneha. So I think I'd send you your marks. So whatever, if anyone wants to see his or her paper, then let me know. I'll show you the paper as well. All right. So now let's practice some questions on this, and then we'll end this lesson completely. Earth magnetism is deleted, no, from your syllabus. It's deleted. So if anyone wants to, we'll do it at the end. It's not that we'll leave it. Okay, Atif, did I show you your paper? How much score Atif is scored? So Atif is, I think, has mentioned all the direction. Atif's paper, yes. One paper I remember where every question had the direction, even without asking. See, this is how you have to write it. In the first question, direction and magnitude was asked. So obviously, every step carried a mark. In the subsequent steps, magnitude was, I think, asked in the second question. But you have to show every step, every marking. So this way your questions are constructed. It can happen you're getting the final result, but your marks you're not getting out of 3, you're getting 2 or 2.5 like this. Fine. So just work on these. And again, telling you all, just work on, please work on the derivations part. Just the derivations. I hope I've told you last week only. So it's Tuesday today. Will you be able to give it on Thursday, or should I take it on Tuesday?
Ma'am, can you take it on Tuesday?
Tuesday, fine. I'll take it on Tuesday. So again, you have still 1 week full gap. But Please, because derivations, when I give derivations, even the good students are not able to write it. Derivations, everyone should do. And 4 chapters only. Notes for the derivations. Okay, Sneha. I'll send you the derivations. So till the time, just note down a question and let's practice some questions. Yes, Krishna, right answer. Others also try. This one is a very direct formula based question. Hamza, just check the powers of 10. Is it a typing error or that's the answer you're getting? So, Krishna, Atif, Kulsum, Shara, Hamza, Hanifa. Hanifa again, same thing. Just check the powers of 10. Let me discuss it now. So basically, torque you have to calculate. No, a magnetized needle of magnetic moment is placed at 30 degree with the direction of magnitude 3 into 10 to the power minus 2 Tesla. What is the torque acting on the needle? So this is a formula based question. M cross P, or you can write this as MB sine theta. Now, what are the values that are given? Yes, now it's right answer. So torque will be M is 4.8 into 10 to the power minus 2. The magnetic field you have, this is 3 into 10 to the power minus 2 multiplied by sine 30 degrees. So when you'll solve this, you'll get the answers exact as you people are getting 7.2 into 10 to the power minus 4. And obviously the unit will be Newton meter. So all those who have not written, just note it down. Then one more question I'm giving you. This was a very easy question. Even these kinds of questions come in your board exams. The other question that I'll give you, that is also very important. So this must be the last month of your vacations, no? All of you?
Yes, ma'am.
So August is closed, or the schools are reopening in August? Krishna?
Ma'am, for me, it's like on September 5th, it's starting.
September 5th. And for you, Atif?
For me, it's on August 29.
August 20th. So for others also, I guess the schools are opening in this way only, no? 4th September. Yes, yes. First answer, no question? Correct. First one is right. Others also try. Current is asked. This question has already come in your board exams, one of the previous year's questions. Yes, answers. Only the first answer has been submitted by Kulsum. I is equal to Q by T. And time period, how can you calculate for a circle if velocity is given? By that relation, use it. And do convert angstrom into meters. Second part is also right. Third part caused some slight error in the powers of 10. Just check. What about others? You people are not getting any answers. Last 2 minutes and I'll discuss. Till the time, at least try the first part. That seconds means time, Matif. In the first part, you have to find out current.
Sorry, teacher, there's a mistake. I meant to put.
Okay. No, Krishna. Hamza, yes, your answer is right. Slight error, Krishna, in your calculations, I think. See, let's discuss it now. So it says what an electron moves around the nucleus in a hydrogen atom of radius 0.51 angstrom with a velocity of 2 into 10 to the power 6 meter per second. You have to find the equivalent current due to orbital motion of electron. So yes, Hamza. Hamza, you explain. How did you get the answer? Just explain the method. Yes, Hamza, which formula you used? How did you get the answer? You used I is equal to E by T. Exactly. This is what we all have to use. I is equal to E divided by T. Now E is here. So time period is not given. So how did you write time period, Hamza? Time period is not mentioned. So how should I use how should I use time period? Only these things are available to me. The radius is available, the velocity is available, and I have to find out the current. So how did you substitute time period? Because time period is not given. Yes, Hamza? Your answer is right. Just tell the method. You have got the correct answer. Two pi r divided by exactly. See, time period is not given to us, but time period we can substitute time period as 2 pi r divided by velocity. Velocity goes up. Now we just have to put in the values. This becomes 1.6 into 10 to the power minus 19. Velocity was given to us, I think, 2 into 10 to the power 6 meter per seconds. 2 is there, pi is 3.14, radius is given as 0.51 angstrom. So Sneha, any idea how we convert angstrom into meters? How do we convert angstrom into meters? Atif, can you answer? How do we convert?
1 angstrom is 10 to the power minus 10 meter.
Exactly, 1 angstrom is 10 to the power minus 10. So we multiply this term by 10 to the power minus 10. So when you solve this, you will get the answer as 10 to the power minus 4 amperes. Just check the powers of 10, I think all those who were getting 10 to the power minus 3 amperes. Second part is asking us to calculate the magnetic field which is produced at the center of the nucleus. So, Kulsum, how did you get the second part? Because you were the only one who got all the answers. Just tell the second part, Kulsum.
P is equals to nu naught I by 2R.
Exactly, perfect. See, others. It's a case of what? Circular motion only. Nucleus is there, electron are revolving around it. Radius is r. So magnetic field at the center, formula will be mu naught I divided by 2r. This is the magnetic field we have studied for this at the center of a circle. So magnetic field will be what? Mu naught is 4 pi into 10 to the power minus 7. Current you have calculated in the first part, 10 to the power minus 4. 2 into radius is 0.51 into 10 to the power minus 10. So this way if you solve, you will get the value exact as 1.23 Tesla. Last part says, last part asks us magnetic moment associated with it. So Krishna, do you remember the formula of magnetic moment? Formula of magnetic moment. Sarah? Formula of magnetic moment. Dipole moment we had done. Magnetic moment, magnetism. Sarah? Anyone else who remembers this formula for magnetic moment? I, yes, right. It is current multiplied by the area. Please revise all these formulas, otherwise simple questions you won't be able to solve it. So magnetic moment, this is what? Current into area. Current is 10 to the power minus 4. Area is pi r square. Square of this. So this when you solve it will be 8.16 into 10 to the power minus 25 ampere meter square.
This was the first one, and I'm getting 10 to the power minus 3. I need to do the calculation.
10 to the power minus 3 you are getting. 1.6. Correct answer was 10 to the power minus 4 because I remembered it, so I wrote it. Let me just solve it again. Let me solve it. And see, other people are getting, no, Kulsum and Hamza. You both got 10 to the power minus 4, no?
Yes, ma'am.
Let me see the calculations once, Atif. See, 3.14 into 0.51 is around 1.6, no? So 1.6, 1.6 will get cancelled. So yes, 10 minus 9 plus 6 minus 3, right? It should be minus 3 only. Correct answer will be minus 3. All right, now the last question, but before we move on to the last question, did you people see one table I had sent you on WhatsApp? There was diamagnetic, paramagnetic, and paramagnetic substances, definition and classifications. So the table I've sent you on WhatsApp, anyone who is not on the group, just let me know. Anyone who is not on the group, just let me know, then I'll send it again. So that table is very important, but to understand that table, you have to understand certain terms. The first term is known as magnetizing field. Not magnetic field, it is known as magnetizing field. Yes, Fatima, where were you? I think you were absent for the past 2 classes, no, I believe? 2 or 3 classes.
Teacher, I did the recordings.
Okay, you've seen all of the recordings?
Yeah.
All right, perfect. So magnetizing field is what? When a magnetic material, whenever any magnetic material is kept in magnetic field, then magnetism is induced in it. Any magnetic material is there. Let's say this is a magnetic material. If this is placed in magnetic field, then magnetism is induced in this. Magnetic material means the material that has a tendency to get magnetized. For example, the example I gave you in the last class regarding that iron ball. If you rub it with iron ball, the way I gave you the example with bar magnet and iron ball. No? So if you take a magnet and you rub iron ball, so you'll see iron ball will get magnetized. So that is because of the presence of magnetizing field. So basically you can even say it in this way, that the magnetic field that induces or that exists in vacuum, magnetic field, this term is just similar to magnetic field. The term magnetizing field is just totally similar to magnetic field. So magnetic field that exists in vacuum this is first point for magnetizing field. Second point is that it induces magnetism. Then we call that field as a magnetizing field. The best example you can take of a solenoid, where we use this formula B is equal to mu naught M. All these wires are turned, they are made in the form of wound or rings. So if a solenoid has n number of turns per unit length, then the magnetic field set up in the solenoid is given by this relation. Then we call this as a magnetizing field, not a magnetic field. But there's a very, very slight difference in all the terms that we'll be using. Second term is known as magnetic induction. See, magnetic induction is what? Magnetic induction is basic. You can take the example of any magnetic material. Let's say the way for the construction of toroid I had taken. So any magnetic material I have taken, wrapped up with any spinning currents which has the magnetic field flowing. Then what happens? Current is thrown into it, which comes out. This is what the working of toroid was. So magnetic induction is what? Magnetizing fields and whatever magnetic field is present. Magnetization field, this is what you have studied just above it, and the magnetic field, that we call as magnetic induction. Or you can say magnetic induction, best definition to understand is whatever are the magnetic field lines. Whatever are the magnetic field lines, let's say these are magnetic field lines. So whatever are the magnetic field lines that are crossing unit area normally. area is 1 meter square. Unit area normally we call it as magnetic induction. So all these terms are in daily life. Whenever we use all these terms, we can interchange it: magnetizing field, magnetic field intensity, magnetizing intensity, and all these. But when we have to classify magnetic materials, then we have to have the knowledge of all these basic terms. So magnetic induction, it can be defined as the total number of magnetic lines, total number of magnetic lines of force crossing per unit area normally. Means perpendicularly. Normally, I hope you have understood. Normally term we have used often. And SI unit also you can use Tesla. For magnetizing field also, for magnetic field also. Now there's one term that I used in between, that was magnetizing field intensity. See now two terms are going to come which will be very confusing by the name. Magnetizing field intensity and intensity of magnetization. These are different names. See, this is magnetizing field intensity. Now, magnetizing field intensity is used mostly in terms of current. Whatever is the amount of current that is flowing for a unit length, especially in a solenoid, that is required to produce a certain magnetic field. Some amount of current will be there, and turnings are also present. So this amount of current that is used to produce a certain magnetic field, we call it as magnetizing field intensity. So this is represented through the symbol H. So it's what? It's basically current that I've told you. And if number of turns are N present, it becomes N. This is what is known as magnetizing field intensity. So you can define it as a number of ampere turns. This is known as ampere turns. Number of ampere turns flowing around the unit of a length of solenoid, which whatever is required to produce a certain magnetizing field. That we call as magnetizing field intensity. So in this, we have one more relation, B is equal to mu naught Ni. So if I substitute the value of N becomes what? B divided by mu naught I, no? So let me put the value of N into this. So H will be equal to N is B divided by mu naught I, and current is I. So I gets cancelled. Mu naught or H can be directly written as B divided by mu. This is also what you can replace. And then the quantity that I was telling you, intensity of magnetization. This is what? Magnetizing field intensity. We have a concept known as intensity of magnetization. Now see, whenever a magnetic material is placed in a magnetizing field, it gets magnetized, as we have discussed about the magnetizing field. When we were discussing magnetizing field means this first one. When we discussed this, there we use the term magnetic field. If this magnetic field is replaced by magnetizing field, we can simply call it intensity of magnetization. Better way to remember is that whatever is the magnetic moment developed. Now, you people are aware of magnetic moment. So instead of going the definition of magnetization, intensity, and all these confusing terms, what you people know, you know magnetic moment. So magnetic moment per unit volume is simply magnetization. Let's say magnetic moment is M, volume is V. This is intensity of magnetization. This is magnetic moment, and this is volume. There are few more terms. First, note down these terms. See it, look into it. Any doubts, ask me. Otherwise, then we'll do the other terms. Fine, Fatima, fine. After the class, you just stay.
Is it finished, Scroll?
Scroll up or down. Ataf, you're speaking so fast.
Scroll up. Okay, teacher. Thank you.
see, in this add one more thing that I forgot to tell when I was telling. That total magnetic field that you have to write. This total magnetic field is basically the sum of the magnetizing field plus the magnetic field intensity. Means B naught plus V. So this we had written as what? Mu naught H, and this is written as mu naught M. So your net magnetic field is written as mu naught H plus M. Just add this one also. Now the fifth quantity. From here the quantities are better to understand. All these four were very confusing. Intensity of magnetization, magnetic field intensity and everything. Now you have magnetic permeability. Magnetic permeability is simply the ratio of magnetic field and magnetic intensity. This is magnetic induction. Remember B we had written. This is magnetic induction and this is magnetic intensity. This is magnetic permeability. Then you have relative permeability. Permeability is same. For free space, it is 4 pi into 10 to the power minus 7. Unit will be Tesla meter per ampere and everything. Rest of it remains the same. Now, relative permeability means when you are comparing it with some other media. The way we had relative permittivity, no? Similarly. So, relative permeability will be what? It will be mu divided by mu. This is for free space and this is for a medium. This is for free space. Now you have a term which is known as magnetic susceptibility. That's also important. I think this is seventh one, no? Magnetic susceptibility. This is represented through the symbol chi. This you must have used in your chemistry, I guess, for partial fraction or I think mole fraction. We write this symbol only. So I think you must be aware of this. This is basically the ratio of what? Intensity of magnetization. This is intensity of magnetization to what? To the magnetic field intensity H. Both these terms are very confusing. So this is one relation. Now there is no other term left, but we have a very small relation that all of us should know, and that comes in your exam. A slight relation is there which is present. So that's the relation between, it's the relation. This can come directly to write. Other parts do not come directly, they come indirectly by the usage of diamagnetic and all, but anything can come in the paper as I told. This comes relation between magnetic permeability and magnetic susceptibility. So B is equal to mu naught H plus M, what I have made you right now. And V is also equal to mu H from the formula of magnetic permeability. So if I put this in this formula, this becomes mu H is equal to mu naught H plus mu naught N. Or even if I do not take common, I'll get the answer. Mu naught H plus N. Now, if I divide the whole equation by H, see from here H gets eliminated, from here this H by H becomes 1 and this becomes M divided by H. See M divided by H, just now we have done M divided by H is chi M, that is magnetic susceptibility. So this is a very, very small derivation that comes in exam. Because it is short, so it comes in your 2 mark questions. Fine, so just note this down. See, now basic classification of magnetic materials. So now you will be able to do it. 3 classifications are there in your syllabus. So rest of the things you have to learn ultimately. One table also I have sent you for your help. First are diamagnetic substances. So diamagnetic substances are those substances that develop feeble magnetization. That's why we had used the terms magnetization and all. They develop feeble, this means weak magnetization. But in opposite direction of magnetic field. All right, they are even weakly repelled by magnets. I'll write down. Feebly repelled by magnets. All right, and one more point that you can remember, the rest of the things you have to remember. See, questions come from this. They tend to move from the stronger to weaker parts of the magnetic field. They move from stronger to weaker parts of magnetic field. So various examples are present. Some examples you can learn because you have to answer. So by examples, your answer becomes strong. Materials like copper, lead, tin, zinc, gold, silver, and all these materials, these are enough, sufficient. Now, the next group of material, these things, see, you people have to learn it because there is no logic in remembering all of this. So please learn it. Try to learn it by today and tomorrow so that when we start with EMI, because we'll start with the next chapter now. You have an idea of everything, and these are not piled up. These are paramagnetic substances. Now, just you can do one thing, learn the first one and then see what are the changes in the other ones. Feeble magnetization was here. They also develop, these are those that develop feeble magnetization. So feeble magnetization exists the same. Difference come in the same direction. Fine. Feebly repelled by magnets. So they are feebly attracted by magnets. Like this, if you remember, you will be able to. This is how I remember. Otherwise, I'll also forget all these things. These few points I'm able to remember by, I remember diamagnetic. I just make the corrections in this. And they tend to move from weaker to stronger. Weaker to stronger parts of magnet. Examples, I think water comes in this. No. Water was in diamagnetic, not water. Water comes in diamagnetic. Here you have water. Here you have sodium, copper chloride, chromium, manganese, and all these substances. Some examples, just remember some examples. Nobody's going to ask you and give you a material and ask whether it is paramagnetic or diamagnetic. These are portions of your chemistry that there you have to deal with all these. Last group is the ferromagnetic. These are ferromagnetic substances. Now, what difference comes in this is that they were feeble, means weak magnetization. Here it has strong magnetization. That's it. And in the same direction. This remains same along with it. And regarding they were feebly attracted by magnets, they get strongly attracted. These were feebly attracted. The way they were feebly repelled. First one was feebly repelled. Second one was feebly attracted. Third one was strongly attracted. And regarding this movement, weaker to stronger parts. Weaker to stronger parts. Now examples you can remember: iron, you can remember cobalt, you can remember nickel, you can remember. You must have heard of this, or I don't know. There's an alloy which is known as alnico. This is actually made up of aluminium, nickel, and cobalt. So this is also one of the examples. So these are the major points that I have covered. The minute details, like what happens in case of non-uniform magnetic field, what happens to their susceptibility, what happens to their permeability, all these things you people have to remember it by yourself. So do remember, I'll give you a separate time for that. I'll ask you all these points. At least just learn this table. This you can do. Just note down this. And do text me done once you have written it. What about others? You people have also written. All right, I think most of you have completed it. So one of the students, Fatima, you stay. Rest of you can leave the meeting. We'll start with EMI in the next class. So right now I'm stopping here. Half an hour prior to the main class that ends because new chapter will start from Thursday. All right, so take care. Meet you on 4th. Fatima, you stay.
Thank you, ma'am.
All right, take care. Yes, Fatima. Which portions? Did you take the screenshots from the video lectures, or have you noted everything?
I noted them. I wrote till classification of magnetic materials. No, I'm sorry. No. There was a question we did last.
These
Show that
questions?
motion of a bar
Mhm,
magnet.
mhm. Yes.
Yeah, I did that question.
Till here you have written, no? From here you have to note it down. Okay, take the screenshots.
Okay, I'm done.
From this question, were you there? No,
No, teacher.
just take the screenshots.
Yeah,
Huh?
I'm done. Yeah.
Do note it down after the class, and if you have doubts, just ask me, or even text. You can text me on WhatsApp.
Okay.
So you're not having your classes now, Fatima? Those extra classes which you used to take, non-academic classes.
No, it's like summer vacations. Just for the month of August.